They gave me a very long title. I decided I would shorten it a little bit and just talk to you really about the regulatory compliance piece of this. So everyone has already introduced quite a lot of different aspects of cybersecurity. I'm going to focus absolutely on a couple of examples of where we've been looking to adhere to regulation. So we're not really trying to protect ourselves in any other way. We're just trying to make sure that we don't fall foul of the regulator. So the first question is, so what? What's the problem? Long time ago, I worked for 10 years for a bank called JP Morgan. You may have heard of them. And we would often sit in a room and decide whether to pay the fine or do something. And so in these cases, SOX gives you a nice fine, about $20 million, 20 years in prison if you're the CEO or CFO, and that focuses the mind a little bit. And it's really about preventing internal interference with the data that is used to create financial reports. So this isn't stopping a hacker coming in and doing something, it's stopping people like Enron from fiddling the reports that are going to be going to shareholders. So it's making sure that we're protected from our own staff effectively, and senior staff at that. And it mandates a few things. I'm sure you can read that as well as I can. The other one then is GDPR, which was a bit of a storm in a teacup a little bit, wasn't it? We all got very excited about it. We all thought we were going to get fined very badly, and so far I haven't heard anything very much going on with that, but I'm sure one day it will hit someone, and it'll probably hit someone who's worth a few quid. 4% of worldwide revenue. If you're IBM, that's quite significant. Take you a few years to pay that one off. Or 20 million euros, depending on which one's the smallest. So either way, it's a really big deal. And for GDPR particularly, and some of these others as well, the way that it works is that you're guilty and you're going to pay the full fine, and now you've got to explain to the regulator why you've put a lot of things in place to try and protect yourself and make sure that you are actually being competent and have oversight and so on. So you have to start at 20 million and work back, which never seems fair to me, but the VAT man does the same thing, so kind of how it works. So I'm really looking at a couple of examples. As people have already mentioned, there's 1,000 ways of skinning all of these cats. I'm just looking at 2 ways that we've looked at doing this. And the first problem that we're trying to address is that you can't monitor yourself. That's one of those ones I think Alan Turing came up with some time ago. But we could write the best applications on the planet and make them as secure as we possibly could make them, and we would have no confidence at all that we'd achieved what we wanted to, and we'd have no confidence at all that they would remain secure. So anything we do is subject to corruption. So the control of something and the oversight of something must be separate. There's no real, you're breaking the laws of physics if you're trying to do anything else. So that's the first problem that we try to address. The second one is then to try and implement security with overlap. So what we're trying to do is to make sure that, and I'm not a Latin speaker, but who watches the watchers? We need to make sure that what we've put in place to have oversight is itself able to be confirmed as being accurate. And we're looking at the network, we're looking at the applications, and we're looking at the data and the oversight. But as I said, I'm coming at this from the perspective of a board who want to inflate their stock artificially or to do something internal. So, bottom line, applications can't be trusted with compliance, so we need to do something else. We need to be able to detect the problem, and that means we need to watch for it. We need to be able to prevent the problem. Now, the applications are going to be doing their best to do that, we hope, but we still have to be there in the background and be capable of preventing that problem. And we need to be able to somehow correct the problem. And I think with Nationwide, you were talking about that earlier, that if someone has corrupted your data, how the hell do you know that? And once you do know it, how do you recover from it? If I lose something and I know I've lost it, that's one thing. If I lose something and I don't know what I've lost, that's quite another. So how do I address these things? So, IBM Guardium, I thought you were going to steal my entire presentation, so thank you for not doing that. IBM Guardium is a product that has been around for actually a very long time, certainly over 10 years. It's evolved in that time. And one of the things, having been involved with IBM software for some time myself, that is really lovely is that you can come across a product that's been around for 20 years and it's as advanced and as forward-thinking as any product you'd find on the market. And I think Guardium is one of those. I was reading the books last week, so I knew what to say to you. And I thought I knew a bit about it, but I was quite stunned at how much I didn't know that was in the product. So I would urge any of you, if you've used this or you have it, go and read the manual again or get someone else to, because it's quite boring. And just see what's in there. There's tons of stuff in there that I hadn't appreciated myself. What we're using it for is to detect and record access to databases. We want to filter that information, so we don't obviously want to collect all of the data that's going backwards and forwards, by user, by address, i.e. TCP IP address, by where they are in the world, what are they doing, what kind of object, what table or file or whatever it is that they're trying to access, and what time are they trying to do it. So we might have someone who's perfectly entitled to access a file during the day, but when they're accessing it from their bedroom overnight, we kind of want to know that, and we want to think about what goes on. We want to be able to prevent those data collections. So if we say someone leaves the company, we want to shut off their access to data, we can do it this way. I know there's other ways of doing that, but we could say, if this person, this username, is used to try and connect to a data source, I'd like to disable it and tell someone. And then the tamper-proof. We're all using open source. When I ran stuff in JP Morgan, if I'd have said to someone, I want to install some open source in production, I know I would have been shown the dole queue at the time. It was just a no-no, absolutely not. And yet now, I wouldn't like to guess what proportion of software is either directly open source or open source in someone else's product. So how do you know the veracity of that code? How do you know, it's been written by developers over several years. I've written code in my past that assembled things at runtime so that you couldn't scan it for things. I won't tell you why I've done that, but fundamentally you won't be able to find these problems until they actually come and bite you. So this is an independent way of all of that code, so it's very difficult to tamper with. And it's independent of the process and the data. So if you've got a process that's not quite right, you don't know that. I was watching a program a few years ago where someone was talking about a cult, one of these religious cults, and one of the people who'd escaped from it said, let's get one thing straight, no one joins a cult. They join what they think is a good organization, but then turns out to be a cult. And I think the same is true of a business process in an organization, that you build your business process thinking it's the best process and it does what you want, and it turns out it doesn't. Sorry, that was a bit of a segue there, but so it's tamper-proof in that sense. So Responsiv has been doing and is still doing quite a big project for a very large international bank. We're looking at 200 to 300 databases, and we're implementing Guardium to understand the data and to particularly look out for SOX compliance, GDPR compliance, and several other things that I won't talk about. But fundamentally, we're going to talk to DBAs, and obviously we're asking them, can we go and tamper with your database server? But apart from that, they've got no control over what we're doing or what we're seeing. So the database might protect its data, but it's very dependent on the DBA doing the right thing, the privileged user doing the right thing. And once we're installed here, we see what they do as much as we see what anyone else does. And that's very, very powerful. So it's quite a large project, and we're looking to then extend that out across shared file systems and across the discovery part of the product, where we basically say, okay, we've done all the databases we know about and that we think are important, and now we're going to just scan and make sure that no one puts another database up that we don't know about. So it's a very large project. It's across 2 different data centers. It's got all of the kind of complexity that you're talking about, and hopefully it'll do what we want it to do. I've just told you I can't trust it, so I'll tell you in a few years whether we've been successful with that. So that's IBM Guardium and what we're doing there. Now, that gives us independent oversight, but what about things like GDPR consent? And what about trying to simplify the security environment so that the other tools that we've talked about can actually do their job? And I was trying to think of how to illustrate this, and I thought about Area 51 in Nevada, and I noticed New York on the slide earlier. So does anyone know what happened or what happens, what Area 51 was about? I'm assuming you've all heard of Area 51. Do you know what they did there? What it was for? Apparently, yes. And that's great, and I think that illustrates my point very well. So Area 51 was where the spy planes, the SR-71 and the U-2, flew from. And everyone thinks it's aliens. And an unidentified flying object is probably an SR-71 spy plane that the American government isn't telling you about. Right? So why is it in the middle of the Nevada desert? Why isn't it in New York State? Why isn't it in Armonk? Why isn't it in San Francisco? Because if it was in any of those places, they couldn't have kept it that secret. Right? So the security of that base and all of the people who went off flying around the world was dependent on the structure of what they did, not the wire fences, not the intrusion detection or anything else. It was dependent on how they structured where they put it. The other thing that's nice about Nevada is you don't have to fly across much of America to get out of America and over Russia, which is another good one, isn't it? Because if something is traveling at 5 times the speed of sound across New York, you probably know about it. So it's very interesting that it's a structural thing. So what about GDPR consent and planned intervention? In a multi-cloud environment, and I find we're not a big company, but we're running on about 8 clouds. Now that includes SaaS for us, but we're running servers on 2 different clouds, quite a few of them in fact. So even for quite small organizations, the multi-cloud environment is real, and it's here today. So if I have my cloud number 1, my private cloud, and it's got some servers in it, and every single one of those servers has permission to talk to all of the servers in my other cloud or clouds. I've opened a firewall with all protocols to all places from all places. I've basically said to my mother, I'll be back tonight sometime between 9 o'clock and 3 in the morning. She's got no idea whether to start panicking at 9 o'clock because I'm late or 3 o'clock in the morning. So unless I'm closing the envelope of panic, the envelope of things that are valid, then my security system can't really operate in the way that we'd like it to. And if I open loads of different protocols and loads of different channels to loads of different places, I've basically made it a very difficult environment for me to protect. So directly connecting applications does that. And we've all talked about attack surface. I thought I can't get a presentation deck here without that word or that phrase. It's huge. It's absolutely huge. So what are we going to do about it? The last point there, and I think someone made a similar point, is that in the multi-cloud, in fact in any linked system, the weakest part of that system is the strongest claim that you can make about the system as a whole. So your weakest cloud is your strongest defense here, and that's quite scary, really. So what did we do about this? So again, for a very large organization, we designed, built, implemented, and now operate, and have operated for, I think, 6 years now, an open banking gateway, which I consider to be one of the biggest honeypots on the on the internet. As far as we are aware, given the audience, we haven't had a cyber problem with it. And in fact, when Randori had a look at it, they couldn't find any way in, so that was nice. But we still have to plan for someone breaking into it. And the plan fundamentally was that if you imagine the open banking gateway is the private cloud part, it's got various different servers on it or protocols that it supports, so UK Open Banking and SEPA and so on. And all of those things are not allowed, all of those components, it runs on about 100 cores, so it's quite a big piece of installation. The only thing that is allowed to talk out of that cloud is our bridgehead, right? And the only protocol it's allowed to use is MQ, IBM MQ. So now, if I see any protocol that is not IBM MQ, I want to know about it. And I don't care if it looks okay or not. I want to know about it. On that bridge, I can inspect what's going on, and I can see what I want to do about it. And it has firewalls that actually prevent people from coming in from the bank. So the bank obviously has a network connection. We're running it over VPNs and all kinds of things. But they have a bridge on their side, which looks the same. It runs with MQ and IBM's ACE product. So those two things are clustered together. We're nicely resilient. And they sit there and they make sure that the only communication between those two organizations is MQ. And they make sure that they rewrite things. So when something comes in, if you imagine someone writing a piece of SQL as it comes in through the bridge, we rewrite it. If they've got a piece of text that we want to insert somewhere, we rewrite that piece of text, and we make sure that there is nothing in there, no hidden characters or invalid stuff that would prevent us from doing something. So that bridge pattern works really nicely, and it's been working for us, not just here, we've used it in other places, but this is a good example of it. And because these things cluster and they have high resilience, it scales very nicely as well. So if you've got 7 clouds, you put a bridgehead on every cloud and they can all talk to each other in a very secure way. And I wanted to share that with you because I think it's a very nice pattern. It also goes some way to solving the synchronizing data across your clouds problem. Because it's using MQ and it's asynchronous, we can store everything that goes in and out of that place for a day or 2 days or 3 days, and then we can replay it. So if we know that there's not a problem in it, then we can replay it and build what we want to do. Bit more to it than that, but you get my idea. So I've now reduced the attack surface. No one who breaks into our cloud can get to the bank, and the bank can't get to us, except through a protocol, through packets that we have to expect. We have to understand what that packet is. It's not just an ad hoc thing that goes backwards and forwards. And I think that's something I'd like to share with you as well. There is a white paper on it at the URL at the bottom there, responsiv.co.uk. So, that's what I've just said. Sorry about that. So, detect, prevent, correct. we're using IBM Guardium to do the detection, to understand what's going on with the data, give us the oversight, locate the data by watching for its use. So a lot of overlap with some of the things we've already talked about. So if we see PCI, privately sensitive information, personal, if we see medical data or anything else, we can look for that, and it comes with patterns for us to help do that. If we see lots of SQL errors, we can see denial of service attacks, we can see someone trying to hack a password, we can see all of those kinds of things, and we can respond to those things. So IBM Guardium on the detection and the prevention in that sense. The Cloud Bridge then helps us to prevent attacks by changing the landscape, essentially by putting your cloud into the Nevada desert. And then finally, the correction. Well, if I know what the data should look like or did look like, and I can roll things back, then I've got at least some chance, even if it's corrupted, of understanding what it is I might have lost. And both the Cloud Bridge and Guardium helps me to collect that information so that I can maybe use it later. I mean, even if I know I had 1,000 payments go through and I only got 900, that's already better than I got 900 and I don't know what else should have happened. So that's it for me. Hopefully that wasn't too far over time.